video, I'm going to introduce the concept of concentration. And so there are two ways of considering concentration, qualitatively and quantitatively. In order to understand these, however, I need to go over two key terms. The first is your solute. Now, your solute is going to be the substance that you dissolve, and then your solvent is the substance that your solute is being dissolved in. So one good example would be salt water. Salt would be your solute, it's being dissolved, and water is your solvent. Now, your solute doesn't have to be a solid. For example, if you take water and dissolve carbon dioxide into it, carbon dioxide, which is a gas, would be your solute, but your solvent would still be water. So qualitatively, the way that we describe concentration is we say it's either dilute or it's concentrated. If it's dilute, that means you have very little solute compared to solvent, while if it's concentrated, that means you have a lot of solute and less solvent. Now, quantitative representation of concentration that we're going to talk about before this class starts is molarity. Now, molarity is your number of moles of your solute divided by liters of your solution, the volume of your solution. And keep in mind, your solution is your solute and your solvent combined together.
So this problem is the molarity question, and it's a little bit more complicated than the other example problems that I have you do without me, and the reason why is it really allows us to consider what molarity is and what it's telling us. So just as a review, I'm going to rewrite out the formula that I just gave you for molarity, which is a measure of concentration. It's the moles of your solute divided by liters of your solution, so both your solute and your solvent. Okay, so this problem tells me that I have 250 milliliters of solution and its concentration is this. It then tells me I'm going to add more solid and dissolve it, and it wants to know what the new molarity is. So the first task I have is to determine, well, when I start off, what is the number of moles of glucose that I start off with? Well, I know the molarity is 0.347 molar. And I don't know the number of moles, so that's going to be my x, but I know my liters of solution. If I convert milliliters to liters, that's going to be 0.25 liters. Okay, and so when I solve by multiplying these two together, I find that I start off with 0.08675 moles of sugar. Okay? So I start off with this amount of sugar that I've dissolved, and I'm going to add to that 2.39 grams of sugar. Well, that's in grams, and I want to find the total, so I'm going to get this value into moles so that I can then add my two number of moles together. So to go from grams to moles, I'm going to put 1 mole up top, and I'm going to put the molar mass of sugar, C6H12O6, the glucose, on bottom. So it's going to be 180.156. And so what I find for the total number of moles in 2.39 grams of your solid glucose is 0.01327 moles. And so I'm going to add these two values together. So I'm going to add to this 0.01327. And so the total that I get here is approximately 0.100 moles. So I've taken 0.100 moles, and now I need to find the concentration. I need to take that total number of moles, and I need to divide it by the volume. Now notice that this problem notes that you do not change the volume by adding the sugar. So my initial volume stays the same, so I'm going to divide that by 0.25 liters. And so what I get for my new concentration is 0.40 molar. So notice what this problem had you do was recognize, all right, if I have the molarity and the volume, I can figure out how many moles of my solute, of my solid I have. Then I'm going to add more solid to this to find the new total number of moles, and then I can take that and divide it by the original volume, since volume doesn't change, and that gives me my new concentration. Notice my new concentration is 0.40, while it used to be 0.347, which makes sense because my solution is becoming more concentrated.